Hello everyone, this is Morteza Moghadasyan from University of Toronto. Sorry that you can see my face. I had trouble connecting my camera to the charts, but I hope that all of us can meet on Friday. So there is a part of the discussion that I would like to exclude from the Friday's presentation and provide you and record it for you and provide you with access to those materials sooner than the Friday session, with the hope that you can watch the video and perhaps bring your questions to the classroom. This way we can answer more questions and hopefully save some more time for the hands-on exercises that we are going to do. So this part is with regards to the SAVI testbed and the software-defined infrastructures and how we actually and how we designed the SAVI under the hood as a software-defined infrastructure. So as you might already know, SAVI stands for Smart Applications and Virtual Infrastructures, and SAVI has been an NSCERC funded project and also led by a close collaboration of Canadian partners, industry, academic, research, and education networks that they all led the project with the hope to enable research and provide testbed on application platforms. And since then, there has been multiple universities, senior researchers, and graduate and postgraduate students and industry partners that they all came together and contributed to the project. So the idea of SAVI is to build and provide a multi-tier cloud testbed. And by multi-tier, I mean there are core nodes and edge nodes and access technologies that can connect wide-ranging, heterogeneous devices to the smart edges. So core nodes are these massive scale, large data centers with different type of resources and also many resources that they have in possession that they can provide to your applications. And then edge nodes can provide the same set of resources, but also in a smaller scale and closer to the end users. And then the access technologies, as I mentioned, I mean, different type of access technologies, wired, wireless, and optical, can connect different type of devices to the SAVI testbed through the smart edges. And then, sorry, the smart edges and core nodes, they interconnect using the SAVI dedicated network, which we also call it the backbone network. And this backbone network is built on a partnership between industrial partners and provincial education networks that they together build the backbone networks for us. So in a sense that the smart edges and core nodes are interconnected across the testbed. So, and also the access technologies extend the network, the network of the edge nodes to these heterogeneous devices. So basically the entire SAVI testbed is interconnected and your applications can interconnect with all of the virtual resources and also physical resources that we provide on the SAVI testbed on an end-to-end basis. As I mentioned, the idea of smart edges is basically to take the resources we have on the core closer to the end users, right? So now they can look at closer to end users, and we can use that as an opportunity to support low latency applications. And also the smart edge nodes, they can also provide, virtual access to virtualized and heterogeneous resources. And these resources can be computing, networking, storage resources, other resources also such as GPUs and reconfigurable hardwares, and also the notion of providing wireless access points that allow wireless devices to connect to smart edge nodes is that we can support mobile devices and connect them to the SAVI test. And so now that we know how SAVI architecturally is organized, one thing to know is the notion of software-defined infrastructures, okay, or SDI. So basically, the aim of SDI is to, that we have different type of resources, okay, multiple tiers, different type of resources. But the idea of SDI is to aim, is basically the SDI aims to integrate the management and control of all of these infrastructure resources, all of these infrastructure components, whether they are compute, networking, storage, access networks, and so on and so forth, but build a unified management and control for all of these infrastructure resources, and at the same time provide open interfaces for users and applications to build network applications that work with these open interfaces, and provide additional services. Another important fact about the STI is that the management, the control and management, the unified control and management of all of these infrastructure resources is provided through a centralized viewpoint of the entire infrastructure by building a logical and central, control plane that is implemented in software. Because, as I mentioned at the beginning, SAVI provides the software-defined infrastructure. So SAVI is actually an SDI. So from the perspective of SAVI and the notion of SDI that we just discussed, the way that it works is that what I mean is the way that the centralized viewpoint, the central control plane works is that there are different type of resources. Okay, there are group of resources, physical resources, virtualized resources, other type of resources. Okay, which, for instance, in this figure I was trying to provide resource A, B, and C groups. Okay, and since they're different, each of them are managed and controlled by different type of controllers that manage and control its own device types. Okay, and each of these resource controllers talk to the SDI manager, and the SDI manager, and through the SDI manager, they can be configured, and they can be they can be attached to networks that enable them to communicate. And then the SDI manager itself is interacting with a monitoring service. The monitoring service also collects state information from the resource controllers and provide that to SDI manager so that SDI manager can make decisions about these resources. And then both SDI manager and monitoring services, they provide these open interfaces for external entities. So one thing that I wanted to share about this figure is that when I say we provide a logically and centralized, control plane for the entire SDI, that doesn't mean that the controller resources must also be in one place. Okay, they can be physically distributed in the network, but they all together, they build this centralized viewpoint, logically centralized viewpoint over the entire infrastructure resources. So final point about this chart is that so each type of resources work with the SDI manager through their own resource controller. But however, in another viewpoint, within one SAVI node, okay, within one SAVI SDI node, which includes the entire testbed of a SAVI, okay, there are also controllers that we need to manage not only different type of resources which we discussed, but also the interaction of these resources and their needs in over the virtual platform that we provide on top of the SAVI physical testbed. Okay, and those controllers, they also interact and communicate with the SDI manager. And so they also enable the SDI manager to control its software-defined, infrastructure. And in SAVI, we use OpenStack to manage these computing resources. Okay, so there are physical resources, there are virtual resources. Okay, they all can be managed by OpenStack. However, I want to also again call back on the previous figure that we had different type of controllers. So those controllers also are specifically designed for different type of resources. So all together they build through this ecosystem and interact with the SDI manager. However, there is also networking that interconnects these computing resources and enable them to interact over the SAVI testbed network. And for those, we used OpenFlow controller and the OpenFlow protocol to talk to these resources and enable them to interact with the SDI manager. And as also mentioned in the previous chart, the monitoring and analytics component works in between all of these components. And so then the open interfaces are provided to external entities. One thing that we need to know is that, well, if you think of these components separately, okay, OpenStack, OpenFlow controller, they're not meant to be easily integrated. Regardless of that, we have them in SAVI integrated, but that's the job of the SDI manager software, okay, a controller of controllers, okay, that build this entire networking and compute and storage all together. In other words, converged infrastructure. So that's an important point to have in mind, because if you think you can build this as SDI infra, if you think that how you can build this SDI software-defined infrastructure, but also manage it. Okay, so you have these different components that you need to hack them together in such a way that they provide an efficient way for you to manage infrastructure. And that's the software that we built, and we actually enabled SAVI to do so. So the SDI manager and all of these components that allow them to work with each other, they are the software that you need to build to manage such an infrastructure. So also, if you think of the test bed, as I mentioned, it's a multi-tier test bed, right? So that means there are core nodes in the infrastructure, there are edge nodes, and they're all connected through this SAVI dedicated network, which we also refer to that as the backbone network. Okay, but then all of these nodes, they each might have a different type of services that they provide to end users and their devices. But then there are also testbed-wide services that all of these nodes will have access to. Okay, and then users who interact through these services, they go through a testbed-wide open interfaces that allow them to interact with these services and with different nodes on the infrastructure that are attached to these services. Okay, so one of them is the identity and access management. So and anytime you need to access any resources on any time on any of the edge and core nodes, the verification of users' credentials and all of those, and even defining keys and everything, they all go through these testbed-wide service that provides identity and access management. There is also a web portal that allows users to have a graphical way of interacting with the testbed, but also we will have some hands-on exercises that we will do on Friday, which we actually do these using, the client libraries and APIs that we provide to you. And then there is the imaging registry that you can use those images as during the deployment process of your virtual resources and build your virtual resources based on those images. And then there is orchestration that makes decision on where to deploy any resources or how to deploy them and so on and so forth. So these services are also provided across all of the edge nodes, but and core nodes. So all of the nodes in the testbed, but there are also specific services that each of the nodes might also provide. So let's then discuss one of the operations that we do and handle on an SDI as an example. So let's imagine how do we boot a VM. So because the software-defined infrastructure provides you with access to both physical and virtual resources, and creating a VM is one of those virtual resources that you can create on such an infrastructure. And then the idea is how this VM is created, how it's booted, and how it keeps itself connected to the testbed and to other VMs or physical resources that are connected also to the testbed. Okay, so the idea is you've got this OpenStack because we start from the compute, right? The OpenStack manages the compute. So basically, first a user request is made to create a VM to OpenStack. And OpenStack is that controller that helps you with the management of the compute resources. And that also then triggers the SDI manager, informs the SDI manager of the request. And then at this moment, the SDI manager interact with the topology manager, okay, to know and coordinate the topology manager to know the availability in the infrastructure and understand where to deploy your resource, okay? And through that, the SDI manager comes back to the OpenStack and tell the OpenStack controller to boot up your resources and provides additional information for the OpenStack controller that the controller needs to do so. Okay, so once that happens, then your new VM is created, and it's somewhere, okay, in the test bed based on the prior steps. But now the VM needs to be connected to the network and to the rest of the resources so you can actually reach to your VM. So then the idea is that the OpenStack boots up this resource and notifies back the SDI manager by the MAC address and IP address and all of the networking identifiers, networking IDs that identify your new VM to the SDI manager. But now the SDI manager can talk through OpenFlow controllers with with the networking devices that enable the interaction of your new VM with other VMs or physical resources that are available in the infrastructure. And so in such a way that the SCM manager now sets the passes in the routers and enable these interactions. Okay? So then basically then your VM can talk to other VMs. And the idea is that you can have these open flow controllers pair switches in the network, okay? But I'm just gonna talk more about it. So but okay, so one thing is your VM got booted, okay, and it's now connected, and there are rules that have been installed, okay? But when we bring the VM to the network, okay, the SAVI goes with the idea of proactive rule installation, okay? So I mean, by proactive rule installation, that means the network is ready to enable communication between your VM and other VMs on the testbed prior to all of these communications to happen, okay? And so these installs rules proactively on the networking elements. For instance, you can see between A and B and A and C, okay? And then that also removes the need for broadcast-based protocols like SDP to do so. And once this infrastructure is ready, then we can also, during the proactive process, okay, we can also think of different ways, different criteria and considerations to have in mind while we set up the forwarding passes in the data plane for your resources. We can think of load balancing, okay, in the core network and in the access networks that connect them to the core networks. We can think of fault tolerance, meaning we can devise, statistically decoupled passes so that when a fault happens, we can divert the traffic quickly to another. And we can also have this scalability, in mind. And because of that scalability, for instance, we can have like one open flow controller per each switching element that you have in the infrastructure. But remember that they're all collectively work to set up this infrastructure for you. But one thing to share before we move on is that the proactive rule installation works in this way, that now that your VM connects to the network, okay, we proactively install these forwarding passes in the infrastructure that connects your VM through its network that it's connected to other networks that have these other virtual and physical resources. So an end-to-end communication can happen actually um, pre-handedly. So now that whenever you approach interacting with other resources, the network is ready to accept and enable your interactions. But we will discuss these things more in the hands-on exercise. So there are some final notes I would like to share with you in terms of the SAVI's international collaboration over all of all of these years. We can refer to multiple type of collaborations that happen. So first of all, the SAVI was a partnership across multiple universities in Canada, interprovincial, networks has been collaborating with each other to build this infrastructure, and so there were at some point there were about 10 universities, partnering with each other to build this Canada-wide test. But also we had a partnership with international partners such as one node that we had on South Korea, and then the entire nodes were part of the same testbed. So by actually connecting to the node we provided in South Korea, you could actually reach the entire testbed. And then SAVI also has been federated with Genie through layer 2 connection and also to Internet 2, which also extend beyond Genie to Chameleon and Cloud Lab and so on and so forth. So this international partnership has led us to experience interconnectivity between SAVI and our SDI with other similar type of networking testbeds. So the current status of SAVI as of 2018 and forward, moving forward, is that we have a lot of resources. Okay, we provide like something beyond 3,700 CPU cores and about close to I think 1 TB of RAM. And there are plenty of storage that we provide, access to GPUs, FPGAs, and SDRs and wireless nodes, and also beyond 100 type of IoT devices that you can connect to our testbed. And so the notion of having these SDRs and IoT devices is to enable wide scale 5G LoRa virtualization experiments. If we enable this, then we can let different type of applications to connect to SAVI, and also we can use SAVI to build different type of application environments. And also in the past few years, again after 2018 until now, we have also added 2 more high-speed data centers, the north of Toronto, that we interconnect them to SAVI. So those also expand the network reach to other geographical regions. And so a few samples of the projects that have been done on SAVI that you can also think of them in terms of how an SDI infrastructure, how a software-defined infrastructure can enable this type of projects. Are one of them is the reconfigurable hardware virtualization. Okay, so FPGAs, virtualized access to FPGAs can be provided through and has been provided on SAVI through the smart edges. So basically, you can access to them through the smart edges, and then connect your FPGA applications to the entire network testbed that also allow you to interconnect and interact with other applications of different types. Then the orchestration and monitoring has been a big project on SAVI. So basically monitoring the infrastructure, collecting various telemetry from the infrastructure, and then use them for analytics, which is also one of other projects, and then build this inside and maintain it from the entire network infrastructure. There has been also projects that we worked for content delivery on SAVI, and by content delivery I mean experiencing different type of future internet architectures, and mainly the notion of content-centric networking, which allows content to be accessed directly without needing to know who is providing them, and this can happen through the abstraction of names instead of addresses. So basically, contents provide their own names, and you can identify, and the network can identify and move their data packets based on their name, as opposed to an IP address. And that's an interesting way of distributing content on the network. It has its own attributes, but it also provides so much flexibility to distribute content for content-oriented applications. So we had this project that we began by running CCN on SAVI first, and then extending the notion of CCN through XCCN, which allows you to have long-term subscriptions for content on the network, and then a recent project called Yodel that builds an entirely new content-centric architecture that can support global scale content-oriented applications. Moving forward, the security of NFV and service chaining on SAVI has been other type of projects that we supported and covered during the past several years. We will discuss more about NFV in the upcoming sessions that we have over SAVI testbed, and also the project that we had, and it has been active for several years and is also going through some renovations to be active again, is the connected vehicle and smart transportation. So CVSD at some point has been collecting about 10,000 beyond the data streams from different type of sensors from across the GTA and also beyond, including the bus's location, the TTC bus's location, subway locations, and also the speed on the streets, the direction that the buses travel, temperature sensors, air quality sensors, border crossing time, and so on and so forth. And the project has been huge, and through the renovations that we are working on currently, it's going to be turning into a data collection and analytics platform that is running on top of SAVI. Well, thank you very much for your time. Please watch the video and bring your questions to the Friday session. I will be more than happy to answer all of your questions. And thank you very much again. Have a great day.